Hey, here we go. I just wanted to check to see how you did first of all on those slides. I don't have many responses at this point, but I'm sure I'll be getting some more in. So I just kind of want to review a couple deals with you on those things, make sure that you're kind of getting them right from the slide presentation from Tuesday. So let's see if we can find that. I think I have it right here. Here it is. I'm going to go back to this. Let's see if I can go back to that. Turn this on. Now, let me refresh this here. Okay, and there. So this was what you were supposed to do. We got an image here of Robert. Obviously, he's the tall guy next to his father, and you were going to take some measurements and check to see by just measuring right off the screen using a ruler and compare the two heights, find some scale factors. Let's see. Well, we got measure the height. You're going to do that. Then we're going to look at the real height. Again, you can use proportions for that to find that one. So just off of my screen here, all right, if I'm going to do that, I'm going to go ahead and take my ruler and I'm going to measure. And I can use centimeters or inches. It doesn't make any difference. So let's see. I'm going to use this here, use some inches, and you can't see anything that I'm doing, but you can trust that I'm getting a ruler out, and I measure out the dad's height to be about 3, and Robert's to be about 4 1/4. So I'm going to go into here. So I got dad here. Okay, so we're going to say that he was 3. All right, I got Robert over here, and I'm going to say that he was 4 1/4. All right, now I want to compare that to their real heights. Okay, so then I can set up a proportion for this. We'll look at it that way, and we'll look at it through a scale factor. Now I need to find the real height. So I'm going to go back, and I'm looking at Robert's real height right now. It was 8.9 feet. So 8.9 feet is going to go there, and I want to know what dad's real height is. Check that out. So now all I'm going to do here is cross multiply to find the answer. So I'm going to go 3 times 8.9 like this is equal to 4.25 x's, and then I'm going to just divide by the 4.25, and that way I can get the answer. Alright, so let's do this. 3.89, so I'm going to get my handy dandy calculator out here. I'm going to go 3 times 8.9 divided by 4.25 equals 6.28. So his dad was, now we can't say that's 6 foot 2 inches because this is in a what we call base 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we start over. That's our counting system. But measurements in inches and feet, there's 12 inches. So it's in a different base. So 6.28 doesn't mean that they're 6 feet 2 inches tall. It means that they're 2/8 of a foot. All right. So actually, if I was to take 0.28 times 12, that would tell me how tall the dad was. But since Robert's is 8.9, we're just going to leave it in that. So that's how you can set up a proportion to do it. Now, you could also use scale factor on it if you wanted to. So it really doesn't matter which way you do it. You could use either way. How could you use scale factor? Well, we could look at the 8.9, which is what Robert was, divided by 4.25. This is going to give me the scale factor between what was in the image and what's real. So if I go 8.9 and I divide that by 4.25, I get 2.09. So that means I should take the 3 inches, which was how much the dad was, and multiply that by 2.09. And that will tell me what his height is. So if I go times 3, I get 6.28. No surprise, you should get the same answer. All right, so it doesn't really matter which way you do it. All right, we're going to do a little bit more of a scale factor next week, but for right now, we're just doing this. So either way, proportions or scale factor, however you want to do it. I want to go, let's see, there was a couple other things here. So what about would you find the scale factor between a person's height and Robert's height? All right, well, let's compare him to Zion Williamson. So here's Zion here, all right? And for those who don't know who he is, he's a beast of a basketball player, a rookie this year. Of course, his rookie season got cut down a little short because of the virus
with
thing.
the right hand.
But anyway, yeah, so he was 6 foot 6 inches. And let's
look at it again. It's just one dribble here.
What one bounce, 1, 2. So I'm going to go with this. So if we know that Zion, all right, let me draw here. Zion, okay, is 6 foot 6 inches, and the nice thing about that is I can convert that to a decimal because I know that there are 6 inches in a foot. So then that would easily be 6.5. Because there's 6 inches in a foot and 6 of them 12 and so forth. So that's 6.5. Now we can say, all right, if we have Zion at 6.5, right, and we have Robert at 8.9, how many times bigger is he? So let's divide this out to find the scale factor between Robert and Zion. So now I'm going to take 8.9 and I'm just going to divide that. And I get 1.36. So this scale factor between these two, then if they are similar, all right, so what does similar mean? Well, similar means that they are the same shape but a different size. I'm going to move that and write that down. What does the whole idea of similar mean? Okay, similar, okay, same shape. Got a little ahead of myself here. Same shape, different size. Same shape, but different size. I'm trying not to write so it taps so much for you guys. Same shape, different size. So if they are similar, then that means that they should have the same scale factor no matter what. All right, so that basically, remember we were talking about that model idea. All right, so if we drew a picture here of Robert, okay, and then a picture of Zion. All right, so this isn't quite to scale here. Let me make this just a little bit bigger. So, boom. Something like that. If they have the same kind of measurements, then we could say that they are similar. All right, so let's check that out. So now we know what the scale factor is. All right. One of the things they talked about with Zion is they gave him a wingspan. Well, I wonder if Robert had a wingspan. So let's go check to see if he actually had a wingspan. And I think that was in this lad. So arm span is kind of the same. So this was in centimeters. Let's see, 113.8 inches. That's got to be, it can't be feet, obviously. So it's 113.8 inches. So let's go back and see. So we got Robert at 113.8 inches. That's his arm span, which is pretty much the same. All right, so we know the scale factor between them, right? So we know that Robert is 1.36 inches, or 1.36 times bigger So let's take and divide this 113.8 by 1.36, and let's see what that is. So now I'm going to take 113.8 divided by 1.36, and I get 83.67. Now remember, that's inches, all right? So now I'm going to divide that by 12 to see how many feet that is. Well, first of all, let's see what they give it in. So I'm not 100% sure. So then we're going to go back to here and to here, and it says that his wingspan was 6'10". All right, well, let's figure out how much that is. So I'm trying to draw here. 6 times 12 is 72, plus 10 is 82. Look at how close that is, only off by about an inch. So they are pretty similar, because they're not that far off. I mean, you think 1 inch shouldn't be exact, right? An inch isn't that much. I mean, we're talking about, two objects, two people, and if they're pretty close, if we were off by 5 inches, I'd say, they're not very similar. But 1 inch isn't a whole heck of a lot. So Robert and Zion are pretty dang similar. All right. Yeah. So that's what I wanted to make sure you kind of got. All right. So when you're doing some of the problems, then you won't have any issues with things. Let's see what else is on that slideshow there that I need to worry about. So you were doing some other collecting of measurements. All right, you can look at, we talked about hand spans and seeing what that is, and getting a feeling for how much Robert's hand span is. And that's, again, is going off the idea that, you are similar, okay? So it really does make a difference whether you're similar or not. Let's see. So let's do just one more little measurement here, a foot. So for example, let's take myself. All right, so I'm going to take and measure my little shoe length here, and I got, just about a foot. Okay, so just about a foot. So that's 12 inches. So my shoe that I have on right now is 12 inches. All right, and my height is 5'10", so that would be 70 inches. So if I want to check to see if I'm similar or not to Robert, then what I would have to do is find our scale factor. All right, so I'm going to go my height over my shoe. I want to take 70 and divide it by 12, and I get 5.83. Now let's do the same thing for Robert, right? We're going to take his height, right, which remember was 8.9 feet, and divide that by his shoe. So I'm going to go back and find his shoe, and I think that was in here. His shoe length was 18.5 inches. Okay, so I had to kind of go back and insert this part here. Okay, so we were looking at this, and I said, okay, we got Robert, who was 8.9 feet, but the problem is that we have to convert that because my height was in inches. So then we're going to take 8 times 12, first of all. That's going to convert that to inches. All right, so right now I got 96. That comes from this part right here. But now I have to deal with the 0.9. And that's what I was saying before, is that because 8.9 is in a base 10 system and inches and feet are in a base 12 system, they don't cross over very well. which is one of the advantages of the metric system because it's in base 10. So anyhow, we got to change that. So what I'm going to do is just take 0.9, because that's and multiply that by 12 to see what that is. So I'm going to go 0.9 times 12 to see exactly what inches that is, and we get 10.8. So I'm going to add 10.8 to this. So that would be 106.8 inches is how much he is. Now we're going to divide that by his shoe, which was, I think, 18 point, let me see what it is. I think it's 18.8 is what we had. Oh, I got it on this slide. 18.5. So we're going to divide that by 18.5 and check to see if we have the same scale factor. So 106.8 divided by 18.5 equals 5.77. So 5.77, again, that's pretty close to 5.83. I mean, they're not off by a whole lot there. So you could pretty much say that Robert and I are kind of similar. I'm just a little scaled down version of that guy. He was super tall, and I'm not, but we're pretty dang close. All right, so yeah, and that's how you do it with scale factor. All right, you could do it with proportions also, simply by just going 70 over 12, right, equals his height. Remember, that has to be in inches, so I have to do this over x and cross multiply and see if I get the same answer as this 18.5. All right, so I'm going to do that real quick. 70, oops, I was going to do it real quick. 12 times 106.8. Oh man, I just screwed up. This is what happens when you hurry. 12 times 106.8 divided by 70. And that was completely off. 12 times 106.8 equals that, divided by 70 equals that. So it should have been 18.3, right? And 18.3, look how close that is. Look. So see, we're really similar. I mean, you're talking about 0.2 of an inch, is no heck of a lot. So kind of cool stuff.